So just for completeness, let's also look at a couple of animations of the thermohaline circulation that we mentioned. So we talked about how there are places where water is sinking and then it's flowing through the Southern Ocean into different oceans. So here is the Pacific Ocean. Cold deep water is coming in, crossing the equator, going into the North Pacific, slowly becoming redder, which means this is cold heavy water. It's becoming lighter water because of this mixing of the tides and so on that we mentioned, and that then flows south and goes towards the Indonesian region. Remember, there is a gap here, so the water flows through the Indonesian seas from the Pacific Ocean into the Indian Ocean, which we mentioned as Indonesian through flow. So there is some heat and fresh water that is coming, fresher water coming from the Pacific Ocean into the Indian Ocean, and Indian Ocean gets also some cold heavy water that gets converted into the surface water as blue gets redder and comes back out. The unique thing, if we stop this here, is that the Indian Ocean is cut off to the north because of this continent. This is the reason why we have the land sea breeze kind of monsoon circulation. Now in May the land is tremendously hot. A lot of convection or rainfall is already happening on the Bay of Bengal. You may have read the India Meteorology Department announcing that the monsoon has arrived on the Andaman Nicobar Islands here. It will keep continuing and hopefully arrive soon on the Indian subcontinent over Kerala and then northward around June 1st, as it usually happens if it's on time. So this cutting off here forces the water to come up and go south and then become part of the upper branch of the thermohaline circulation, which mixes with this branch of the thermohaline circulation coming from the Pacific as Indonesian through flow, and together some of it goes around the southern tip of Africa back into the Atlantic Ocean. Some of it retroflects or returns back. So this is the Agulhas flow here, Agulhas outflow or leakage as it's called, Agulhas retroflexion or return flow here. So you can see that some of that warm water is also circulating in the Southern Ocean. Remember, Southern Ocean is forming some heavy water in the Ross Sea, Weddell Sea region, where again evaporation, sea ice, other things are creating salty, heavy, deep waters, and they are mixing. They are going around the Southern Ocean a few times and then going into the Indian Ocean, the Pacific Ocean, and of course some of it is going as warm return flow near the surface across the equator into the regions in the Labrador Sea and the Jin Sea or the Greenland, Iceland, Norwegian Sea, where the waters are sinking. If you sink the water, then new water has to come in, right? So if you, it's like called mass continuity or mass balance. If you sink the water, you cannot have a hole in the ocean. Other water flows in to sink it, so you bring warm water and heat along with it to sink where the deep water is forming, supply the region where deep water is forming. Okay. So wherever deep water sinks, as we said, it takes carbon dioxide and heat with it. There are other ways in which the ocean takes up heat. So 91% of the additional energy from global warming is going into the ocean, as we said. Now you can see the thermohaline circulation going here together with the western boundary current mixing with the Gulf Stream, going into the Gulf of Mexico, which is here, which is very warm, and come out between Florida and Cuba. Some of it actually goes outside here, the Caribbean as well. All these currents have names. You don't have to remember them, but you should remember these kind of schematics which are broadly showing you the thermohaline circulation or the global conveyor belt. As we said, this takes hundreds to thousands of years to complete the circuit. Water that has sunk and seen the atmosphere and goes to the bottom, goes all the way to the North Pacific and comes back, has a long time to go and come back. So let's see this in another way. This is another thermohaline circulation, but shows it in a slightly different way. So it shows the upper branch of the thermohaline circulation without showing the details of the Gulf Stream and so on. It is showing that heat and mass are flowing to the regions where deep water is forming. So you can see that the currents are going and sinking or ducking into the subsurface, and soon it will begin to show that that sinking water is begin to start flowing south. So you can see these arrows going south, and you can see now the arrows get fancier. So Labrador Sea and the Jin Sea deep waters are forming. They are flowing south in the blue arrows that we saw before. This is not showing blue and red, but it is showing northward flowing warm waters in the upper levels, top few hundred meters of the ocean, and sinking and flowing southward at much deeper levels. The deep water that is sinking and flowing south towards the Southern Ocean. Let's see how far it goes. And obviously it is also trying to show all the mountains and the valleys at the bottom of the ocean. You know, there are mountains that are taller than the Mount Everest in the ocean. Okay, looks like ocean is just flat, but actually, as you probably know, it has massive valleys and mountains. And you can see now the upper branch going north, the deeper branch coming south, and that's going to here go around the Southern Ocean a few times. And here you see the other upper branch, Indonesian through flow, and the Indian upper ocean branch coming and going across here south of Africa, and some of it is going back as Agulhas retrofaction, as I said. And you can more clearly see now here the Southern Ocean currents going round and round, mixing the deep water coming from the North Atlantic and forming in the Southern Ocean and going into the Indian Ocean, becoming surface water and coming back out. So some of it again going here, some of it circulating back, and there is of course the other branch coming here as the Indonesian through flow, which is going to mix with the subsurface water coming into the Indian Ocean and becoming surface water, and so on. Okay, so this doesn't show the Pacific part, it just shows the sinking part, southward flowing deep water, and the Indian Ocean branch. So these are moving in the north-south direction. In the ocean, when we move east-west, it's the longitudinal direction, and when we go north-south, it is the latitudinal direction. We also say the zonal direction when we go in longitude, because it's the zonal direction, and when we go north-south, we call it the meridional direction. So these circulations which are going north-south, mainly going north-south with some east-west circulation, are called the meridional overturning circulation. Overturning means waters are sinking and coming back up, so they are overturning. Okay, so meridional overturning circulation. There is the Atlantic meridional overturning circulation, and the Indian Ocean meridional overturning circulation, and the Pacific meridional overturning circulation. Okay, so that comprises the thermohaline circulation or the global conveyor belt. Okay, so with that, let's conclude this introduction to the thermohaline circulation. There's a lot of physics, the dynamics and the rotational effects of the earth, and why currents are strong and without much phytoplankton and photosynthesis in the west, and why you have weaker currents in the east, and so on. But these are very kind of detailed advanced concepts. If you want to learn about them, I explain them in my oceanography class, and they are very critical. Those currents are very, very important for moving heat around and controlling the climate as well. So they are very, very important, but it's just that you are not ready for it in this course, but if you are interested, you can always follow up. Okay, let's leave this here. This concludes the 4 podcasts on ocean currents. I'll come back and introduce in the next podcast the Coriolis effect just for completion. Then we will look at something called elemental cycles. So we'll look at carbon cycle in a very simple way and the water cycle as well. Okay, see you in the next podcast.